Hello everyone. This is a tutorial on how to use Rhino to turn a plan drawing into a 3D model. Feel free to pause at any time to review any step in the process. Let's get started. Start by making a copy of all of your lines and hiding all other artwork. Switch to your perspective viewport and you can model from this view. Select the boundary of the pool and use the extrude curve command. As I move my mouse, you can see that it's extruding on both sides of this curve. We want to disable that, and now we can see that the curve is extruded in only one direction. We can also make this extrusion solid, but in this case, we do not want it solid. Enter -8 to make this extrusion 8 feet deep. Delete the input line. Switch your active layer to the default layer and continue modeling. Select all of the walls that are outlined in blue and use the extrude curve command to give these height. We want these extrusions to be solid. All of these walls should measure 6.5 feet tall. Delete the input lines. Draw a rectangle around all of the lines that represent the side of the adjacent building to make one solid extrusion 12 feet tall. Use the polyline command to trace over all of the lines that represent the concrete paving in this outdoor space. We trace this line so that it can be one closed polyline that we can then turn into one closed surface. Select this outline and use the planar surface command to turn it into one continuous surface. Delete the reference curve. We can see that the concrete is covering the opening for the pool, so we use the pool extrusion to trim away the part that overlaps in the concrete. We can now use the extrude surface command to give the concrete surface a 4-inch thickness. Draw another rectangle to represent this planting area that should be turf. Move this surface vertically -4 inches so that it lines up with the bottom edge of the extruded concrete. Use the polyline command again to trace the area that will represent the planting surface directly adjacent to the house. When snapping to points that represent the edge of the concrete, be sure you are snapping to the top edge since we will later move this surface down to line up with the bottom edge of the concrete. Use this polyline and the planar surface command and move the surface down to line up with the bottom edge of the concrete. You can either type in a distance or you can snap to the point you want this surface to be. Use these two lines and two other small lines to represent the planting edge between the area of turf and the general planting area next to it. Join these lines together. Use the extrude curve command to extrude it down then move it vertically -3 inches so that it only extrudes 1 inch from above the adjacent surfaces. This low retaining wall measures 3 feet high. Use the extrude curve command to create that. Use another polyline to trace this planting area. Use planar surface to turn the line into a surface. And move it down so that it matches with the bottom edge of the concrete. You can use a rectangle to trace the area that represents this small fountain. Extrude this curve. Make sure that this extrusion is solid and that it measures 1.5 feet deep. Then use the extract surface command to remove the top surface from this solid extrusion. Delete that surface. Use a polyline to trace the planting area on the east side of the garden space. Because there is nothing to snap to in this area, OSnap and Ortho will project an imaginary snapping point that you can use to complete this polyline. Use planar surface and move the surface down to the bottom edge of the concrete. The elevated planting surface that exists within the retaining wall should measure 6 inches below the top edge of the retaining wall. Use a rectangle to model the first stair and extrude it vertically 6 inches. Copy this stair, referencing its own bottom, and snap to its top to create the second and third stairs. Using the Scale 1D command, we can stretch this top step from its 1.5 foot depth all the way over to the edge of the concrete area in this garden. The second reference point will end up being where this geometry gets stretched to. We can use a rectangle to trace this part of the elevated walkway. Extrude this curve to represent a 4-inch thick concrete surface, and move it vertically so that it matches up with the top edge of the extruded step. Do the same thing on the other side of this step. And do the same thing for the smaller paved patio outside of the building entrance. We can see that the elevated walking surface is 1.5 feet higher than the ground level surface surrounding the pool. We want to use a polyline now to trace the area that's going to represent the sloped surface between the lower edge of the garden and the higher edge of the garden. When tracing this line, snap to the top edge of the concrete because we will end up moving this surface down after it's created. Make sure that you're snapping to an intersection of geometry when there is no physical object to snap to. I can use the close sub-option to complete this polyline. This line now represents the boundary of the surface that will show us the slope between the ground level and the building entrance. Use the patch command with these inputs to generate a sloped surface. Move this surface down by 4 inches. We can see that these surfaces now line up where the wrought iron gate is going to go across. It also represents the slope between ground level and 1.5 feet above that. Use the same process to model the other sloped surface on the east side of the garden area. Remember to snap to the top edge of the concrete. Using patch on this outline will give you the sloped surface that you're looking for. Remember to move the surface vertical -4 inches. We now have the subtle slope that represents the bottom edge of this wall. We can now select all of these taller walls and use the Scale 1D command to make up the vertical distance between the ground level and where the lower planting surfaces have been modeled. Do the same thing on the low retaining wall to eliminate this gap. Be sure to do the same thing for the object that represents the house. Switch to the right orthogonal view so that we can define the sectional characteristics of the pool. Draw a horizontal reference line below the bottom edge of the pool. Draw a vertical reference line that measures 8 feet to stand in for the depth of the pool. Move this reference line so that it snaps perpendicular to the edge of the pool. Make 3 more copies of this line that line up with every dimensional shift in the pool from this view. Because we were drawing in an orthogonal viewport, these lines will not have lined up. Use the move command to move each line to snap with the horizontal reference line. Remember to have OSNAP and Ortho enabled, and pay attention to where Rhino thinks that this object should be snapping to. Your snap tooltip should say perpendicular or intersection. Use the Scale 1D command to shrink this reference line from 8 feet to 3 feet to represent the shallow end of the pool. Do the same thing for the middle 2 lines at 5 feet to represent the midpoint of the pool. Draw a polyline connecting the bottom of each of these newly scaled lines. This line represents the sectional condition of the pool. Use the extrude curve command to turn this line into a surface. Move this surface to snap from its lowest corner to the pool's lowest corner. Use the trim command twice to trim these geometries against each other. In the first instance, the pool extrusion is trimming away the excess of the bottom surface. In the second instance, the bottom surface that represents the bottom of the pool trims away the excess extrusion of the pool edges. Join these 2 sets of surfaces together. Use a polyline command to outline the shape of the windows on the surface of the house. You can snap to your original drawing and draw these rectangles flat on the XY plane. Each of these windows measures 4 feet in height, which translates to 4 feet along the x-axis. We will later rotate these rectangles vertically to match up with the face of the building. The boundary that represents the opening for the double doorway is drawn at 7 feet tall. Move the windows to the left 3 feet. This will translate to a 3-foot elevation between the bottom of the building and the bottom of the window. Use the rotate 3D command and define the bottom edge of the door opening as the rotational axis. The start of rotation will reference the flat XY plane that these rectangles have been drawn on, and the second reference point should be vertically 90 degrees away from that, so that all of these rectangles line up with the surface of the adjacent building. The rectangle that represents the building entry should also be moved vertically 1.5 feet. Select all of these rectangles and use the extrude curve command. Make sure that these extrusions are not solid and extrude them through the front of the building surface. Select each of these extrusions and use them to trim holes in the building surface. Each trim will have to be done twice, once for the front edge of the building and once for the second edge of the building. Now use the building surface to trim away the excess extrusions that made the original holes. Join the building surface and the remaining extrusions together into one shape with the join command. Select the outline for the posts of the trellis and extrude these curves 7.5 feet tall. Make a copy of the building edge and the 3 posts away from this model so to create the overhead plane of the trellis away from the rest of the geometry. The first rectangle is drawn at 2 inches by 6 inches to represent the main beam of the trellis structure. This rectangle is rotated vertically and lined up with the edge of the bottom post. This can now be extruded all the way across to the other edge of the top post. Make a copy of this beam off to the left and rotate it 90 degrees to the left. This will represent our first joist that's going to attach to the building ledger. Make sure that the main beam lines up with the midpoint of the trellis posts. Move this joist so that it touches the main beam and the first post. Then use the Scale 1D command to stretch the length until it snaps to the outer surface of the building. Make a copy of this joist so that it exists in the same position on the other side of the trellis. Make another copy so that this joist can exist in the middle point of the trellis. First snap to the midpoint of the outer edge of the post, and then move it outwards until it snaps with the main beam. Make a copy of the main beam so that it exists on the face of the house to serve as a structural ledger for each of these joists to rest on. You can measure the distance between the first and second joists to create a copy of another joist that will exist in the midpoint between them. Since that distance measured 9.5 feet, we are going to copy the center joist 4 3/4 feet down and 4 3/4 feet up. For the horizontal slats on the top edge of the trellis, we are first going to draw a rectangle that measures 1 inch by 1 inch. Orient it vertically and line it up with the outer surface of the trellis. We can then extrude this curve all the way to the other side of the trellis. We now need to copy this piece of the trellis all the way across. We want each of these pieces to measure 1 inch across and be 1 inch from each other. Using the array command, we will first type in 50 to see if that's enough pieces. The X and Y number should remain 1. The X spacing is going to take into account the size of the piece that you are performing the array on. So we need to add an additional inch to that measurement so that all of these pieces are 1 inch apart. 2 inches will represent this correctly. The preview shows us that 50 pieces is not enough to span the entire width of the trellis. We can click on the X number to change this. 60 appears to be one too many. So 59 will be the magic number to get all of the trellis pieces we need. Pressing enter will finalize the array. Now we have the top edge of the trellis. We can make a copy of the main beam to sit on the outer edge of the trellis to serve as a fascia plate. This is a purely decorative element to hide some of the structural work. Select everything that you've modeled in this part of the model and make a copy from where it exists back over to the rest of the garden model. Here's a quick rendered view to see all of the effort we've put in to modeling this garden space. Don't forget to model the benches. You can use the same methods we used to model the trellis. This garden space also has a sculpture and 2 wrought iron fences that exist on the north edge and east edge of this garden space. This garden also has 2 gates on the east side and north side. Don't forget to model the northernmost planting surface in the garden space. Use the Select Curve command to delete all of the extra lines that you used to model this space. We should be left with nothing but surfaces and polysurfaces.